December 12th, 1944. A bitter grey sky pressed low over the frozen Ardennes, its colour blending almost seamlessly with the heavy, snow-laden fir trees and the frostbitten earth beneath them. Ice clung stubbornly to every branch, while mist seeped through the lowlands, curling like ghostly fingers across the valleys and into the forested ridges. Somewhere within this desolate winter landscape, in camouflaged assembly areas hastily prepared in the preceding nights, the tanks of Oberleutnant Friedrich Weber's platoon murmured with life-muffled engine rumbles, clinking of track links, and the occasional cough of exhaust throttles being tested against the cold. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Standing beside his Panzer G, Weber pulled his greatcoat tighter against the biting wind. The temperature hovered well below freezing, and though the crews had been issued heavy winter clothing, the cold seemed to seep into everything, into steel, into flesh, into thought. Weber was 31 years old, a veteran armour officer who had served in France, North Africa, and most recently on the Eastern Front. He understood both the strengths and limitations of his machines, but more importantly, he understood the men who crewed them. His platoon consisted of 5 Panther tanks, representing the peak of German armoured engineering that was still operational in the final winter of the war. Each vehicle mounted the 75mm KWK-42L, 70-gun, a high-velocity weapon capable of defeating any American or British tank at ranges exceeding 2,000 metres, sometimes even farther with ideal elevation and conditions. The Panther's frontal armour, sloped at an aggressive 55 degrees, gave it effective thickness, far exceeding its raw measurements. Allied reports often overstated the Panther's armour, believing it invulnerable from the front, and while that wasn't entirely true, it was close enough to make the men inside feel a measure of confidence, especially now, in this uncertain winter silence. Weber walked slowly along the line of vehicles, his boots crunching into the snow-packed soil. He paused at the first tank, Panther 234, commanded by Feldwebel Hans Gruber, a stout Bavarian with a thick moustache and a laugh that could be heard over the roar of engines during gunnery practice. Gruber saluted briskly and reported that his engine heaters had functioned successfully overnight, preventing the Maybach HL 234 engine from freezing solid, a small victory in conditions like these. Nearby, the crews busied themselves with maintenance checks, clearing ice from periscope slits, oiling the breech mechanisms of the coaxial MG-34 machine guns, inspecting the final drive housings for cracks or leaks. The frigid temperatures made oil thick, hydraulics sluggish, requiring patience and care. A broken drive shaft or malfunctioning elevation gear in the middle of a planned breakthrough would be disastrous. This breakthrough, Weber's thoughts hardened at the word. Operation Wacht am Rhein, Watch on the Rhine, Germany's last great gamble in the West. A plan reaching back in spirit to 1940, when German panzers had sliced through the Ardennes and taken the Allies completely by surprise. Now, 4 years later, 4 long, punishing, exhausting years, the German High Command intended to repeat this miracle. They planned to drive westward, through Belgium, across the Meuse River, and ultimately seize the port of Antwerp. Such a move, they claimed, could split the Allied forces, disrupt supply chains, and perhaps, though scarcely anyone believed it, now force an armistice. Weber did not concern himself with the politics of it. His mission, as stated in his briefing, was simpler. Spearhead the armoured thrust south of the Lochheim Gap, engage any British or American units encountered, and maintain momentum westward at all costs. But he had been in war long enough to know that nothing remained simple once the shooting began. It had been 11 years since he first rolled across training fields in early Panzer I tanks, crude machines practically obsolete the day they were produced, more symbolic than practical. He remembered the chalk dust, the lectures, the diagrams showing lightning arrows slicing through Europe. Tanks, they had been told, were the future. They would be steel fists, fast, decisive, unstoppable. A revolution in warfare. He had believed it then. Some part of him still did. Around him, the forest crackled as the wind swept through. He could hear a tank turret grinding slowly as Richtschütze gunner. Dieter Hoffmann tested the electric traverse system. Somewhere farther down, the driver of Panther 238 shouted in frustration as his starter motor refused to catch. Weber knew all too well that for all their strengths, Panthers were temperamental when it came to mechanical reliability. Their engines, transmissions, and final drives were delicate, requiring careful handling. In warmer weather and on open fields, the Panthers were predators. In deep snow, icy mud, and narrow forest roads, they were beasts that could break themselves before ever finding an enemy. Still, there was pride here. There was competence, perhaps even excellence. His crews knew their machines intimately. They had trained not just to fire accurately, but to spot quickly, to camouflage effectively, to exploit any terrain, even frozen terrain, to their advantage. Each man understood their roles. The commander, always scanning. The gunner, calculating and adjusting. The loader, swift and precise. The driver, sensing the ground beneath the tracks. And the radio operator, translating chaotic battlefield chatter into understandable direction. Tank warfare was not just strategy, it was teamwork, instinct, rhythm. Weber moved next to his own Panther, 232, its winter camouflage pattern applied hastily but effectively, swaths of whitewash smeared over dark olive, breaking up the silhouette against snow and forest. He opened the side hatch and leaned inside, taking in the familiar scent of oil, exhaust, leather, and cold metal. Inside, his crew worked quietly. Unteroffizier Ernst Meyer, his gunner, sat with the binocular sight raised to his eyes, even though the tank was stationary. He was always practicing, always training his eye to scan for silhouettes, for glints of sunlight on armor, for unnatural shapes in trees. Meyer was thin, quiet, introverted. His calmness under fire had made him invaluable. Next to him sat his loader, Gefreiter Paul Lenz, barely 20 years old, but strong, dependable, and fast. He could load a 75mm shell in under 3 seconds, even when exhausted or under fire. He carried a rosary in his pocket, not because he was particularly religious, but because it had belonged to his mother. Small comforts mattered now. At the forward seat, Weber's driver, Obergefreiter Karl Metz, rubbed warmth into his fingers before pressing them on the gear lever. Metz had been a truck mechanic before the war. He had an almost instinctive feel for engines, and though he often cursed at the Panther's design, Weber trusted him more than any driver he had ever commanded. The fifth member of the crew, Funker, radio operator, and MG gunner, Private Martin Fischer, sat tucked behind the radio set. He had just finished performing a calibration on the Fugue 5 transceiver. Communications, Weber knew, would be absolutely critical during the opening hours of the offensive, especially for armor. Without clear radio coordination, entire columns could become lost, confused, or mistakenly separated from their supporting infantry, which, Weber realized, would likely be the greatest weakness in the days to come: infantry and armor coordination. It had been the key to German success in 1940. It had been one of the great failures in 1943. Now, in 1944, no one knew which it would be. He pulled himself into the turret, settling into his commander's seat. The Panther was cramped, but clean, organized, functional, a fighting machine crafted for efficiency. Outside, frozen breath rose from clustered crews as they gathered around a tarp-covered field table, where briefing maps had been pinned down with grenade boxes and toolkits. Weber walked over and listened as Hauptmann Kurt Riemann, the company commander, spoke about the planned movement. "Initial phase begins before dawn on December 16th, Riemann said, his voice firm, despite the cold wind slicing through his words. "We deploy in darkness. Our objective is the Losheim Gap, then beyond it. We must break through the American lines before they have time to react. Speed is essential. Surprise is essential." A low murmur rippled through the assembled tank commanders. They knew the terrain: dense forest, soft ground beneath the frozen crust, narrow roads barely wide enough for a Panther to pass. Speed? Here? It felt laughable. but none of them laughed. Orders were orders. What surprised them, though, was something else. They would not face the Americans immediately. Intelligence suggested the initial units in the sector included elements of the 99th Infantry Division, relatively inexperienced troops, unprepared for offense-focused armoured assaults. But farther west, waiting behind them, were armoured divisions, veteran ones, the 2nd Armoured, the 4th Armoured, the 1st Infantry Division, and the worst one of all, the one that had ruined so many German armoured thrusts in France and Belgium, the American Air Force. But for now, the cloud ceiling was low, snowy, fog blanketing everything. It was the one gift winter offered. Until it changed. On the evening of December 14th, just 2 days before the offensive began, Weber sat inside his tank with the crew, sharing a rare moment of quiet. They passed around a battered mess tin filled with thin stew and black bread. He spoke to them not as an officer, but as their commander, their comrade. "You all know what they expect of us," he said quietly. "A swift breakthrough, coordination, determination. They expect us to strike fast and hard. I won't lie to you, it will not be that simple. We will face resistance, we will face challenges. But remember, you are a crew, you are not individuals, you fight as one." His words settled among them like snowflakes, quiet, unassuming, but accumulating into something solid. Outside, the forest remained silent, waiting. As dawn approached on December 16th, 1944, the roar of thousands of artillery pieces shattered the Ardennes silence. The ground shook, snow cascaded from trees in heavy sheets. The battle had begun. And somewhere among the chaos, 5 Panther tanks rumbled forward, commanded by Oberleutnant Friedrich Weber, veteran of 11 years of armoured warfare, leading one final gamble through the frozen forests of Belgium, knowing that whatever history would record about this offensive, it would remember one thing clearly, that the Panthers of the 2nd Panzer Division fought with everything they had in steel, in discipline, in bitter cold, and in hope. Hope that, perhaps, lightning could strike twice in the Ardennes. Even in the winter of 1944, through the pre-dawn darkness, Weber reviewed his maintenance status one final time. 3 of his 5 tanks were fully operational. 1 Panther required track replacement, a procedure that would take his crew at least 6 hours using their limited supply of spare links. Another vehicle suffered from transmission problems, the Achilles heel of German tank design that had plagued Panther operations since the vehicle's introduction at Kursk in 1943. Weber's maintenance sergeant reported that they lacked the necessary replacement parts to repair the transmission without cannibalizing components from another vehicle. Telling and preparing this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. This situation was typical for German armoured units in late 1944. Despite fielding technically superior tanks, Wehrmacht forces struggled with chronic spare parts shortages that reduced operational readiness to levels far below authorized strength. Weber accepted these limitations as inevitable consequences of Germany's strategic situation. Allied bombing had disrupted production facilities, partisan attacks threatened supply lines, and competing demands from multiple fronts strained the Wehrmacht's logistical system beyond its breaking point. What Weber did not know was that across the front lines, American armoured divisions operated under a completely different logistical paradigm. The 3rd Armoured Division, positioned to defend against the coming German offensive, maintained spare parts inventories that would have seemed impossibly extravagant to German tank commanders. Each American armoured division carried enough replacement components to rebuild their entire tank fleet multiple times over, supported by supply networks that could deliver parts from American factories to frontline maintenance units in less than 2 weeks. The contrast between German and American approaches to armoured warfare logistics would soon manifest in ways that shocked Wehrmacht commanders and fundamentally altered their understanding of industrial warfare. At 0500 hours on December 16, 1944, German artillery opened fire along an 80-kilometre front, beginning the Battle of the Bulge. Weber's Panthers advanced through the snow-covered forests, their engines straining against the frozen ground as crews navigated between dense tree lines. The offensive's success depended on rapid movement to capture American fuel depots and supply bases before Allied forces could establish coherent defensive positions. By the second day of the offensive, Weber's tank platoon had penetrated 15 kilometers into American-held territory. His force had been reduced to 3 operational Panthers after one vehicle threw a track on a concealed tree stump and another suffered final drive failure that left it immobilized. Neither breakdown could be repaired with available spare parts. The crews were forced to abandon their vehicles after removing vital components that might be useful for maintaining the remaining tanks. On December 18th, Weber's platoon encountered an abandoned American maintenance depot near the town of Sankt Vith. Allied forces had withdrawn hastily, leaving behind equipment and supplies in their rush to establish new defensive positions. What Weber discovered in that depot would fundamentally challenge everything he understood about American military capabilities. The depot's primary structure was a reinforced tent complex, covering nearly 2,000 square meters. Inside, Weber found row after row of carefully organized spare parts for M4 Sherman tanks. Complete engines sat on wooden pallets, their protective cosmoline coating glistening in the morning light. Transmission assemblies filled an entire section of the depot, each unit tagged with installation instructions and technical specifications. Final drives, bogie wheels, track links, turret components, gun barrels, and electrical systems occupied dedicated storage areas, all catalogued and ready for immediate use. Weber's maintenance sergeant, Feldwebel Hans Schmidt, conducted a rapid inventory of the captured supplies. The depot contained enough spare parts to rebuild approximately 60 Sherman tanks from the ground up, complete powertrain assemblies, full sets of suspension components, replacement turrets, and thousands of smaller parts filled the storage areas. Schmidt estimated the depot's total inventory exceeded the spare parts allocation for an entire German Panzer division. But this was only a forward maintenance facility for a single American armored division. Intelligence documents captured with the depot revealed that this represented merely the division's advanced supply point. Additional spare part stocks remained further to the rear in Corps and Army-level depots, creating multiple layers of logistical redundancy that German forces could never match. Oberleutnant Karl Zimmermann commanded a Tiger I heavy tank from the 500 1st Heavy Panzer Battalion, operating independently to support 2nd Panzer Division's advance. His 70-ton behemoth mounted the feared 88mm KWK 36L 56 gun, capable of destroying any Allied tank at extreme ranges. The Tiger represented the pinnacle of German tank design, but Zimmermann knew that his vehicle's combat effectiveness depended entirely on its mechanical reliability. Tiger tanks required constant maintenance to remain operational. The overlapping road wheel design, while providing excellent weight distribution and smooth rides, collected mud and debris that froze solid in winter conditions. Each morning, crews spent hours using blowtorches to thaw frozen running gear before the tanks could move. The Tiger's Maybach HL 230P45 engine, developing 700 horsepower, was powerful but temperamental. It consumed fuel at alarming rates and required frequent oil changes to prevent bearing failures. Zimmermann's battalion had begun the offensive with 14 operational Tigers. After 3 days of combat, only 7 remained in action. 2 tanks had suffered transmission failures, the Tiger's most common mechanical problem. 3 vehicles had thrown tracks that could not be repaired without replacement links the battalion no longer possessed. 1 Tiger had experienced engine failure after a thrown connecting rod punched through the crankcase. Another sat abandoned after its final drive disintegrated during a high-speed road march. None of these failures resulted from enemy action. Every lost Tiger had fallen victim to mechanical breakdown, and in each case, the battalion lacked the spare parts necessary for repairs. Zimmermann knew that his remaining Tigers would gradually succumb to similar failures until the battalion ceased to exist as an effective fighting force, not through combat losses, but through the inevitable attrition of inadequate logistics. American armored doctrine approached logistics from fundamentally different premises than German military thinking. The United States Army had studied interwar industrial mobilization theories extensively, concluding that modern mechanized warfare required supply systems capable of sustaining high operational tempos over extended periods. This philosophy emphasized redundancy, standardization, and robust supply chains over individual vehicle sophistication. Major Robert Harrison commanded the 3rd Armored Division's Maintenance Battalion, responsible for keeping the division's 232 Sherman tanks operational under combat conditions. His organization included 4 tank maintenance companies, each equipped with specialized recovery vehicles, mobile workshops, and trained technicians capable of performing complex repairs under field conditions. The maintenance battalion operated on principles that would have seemed wasteful to German officers accustomed to resource scarcity. Each American armored division carried spare parts equivalent to 15% of major component requirements in division stocks. An additional 25% sat in corps-level depots, with another 30% available at Army-level facilities. This layered system ensured that maintenance units could access necessary parts within hours for routine repairs or days for major overhauls. The redundancy built into American logistics networks eliminated the spare parts shortages that plagued Wehrmacht armored operations. Standardization multiplied the effectiveness of American spare parts systems. The M4 Sherman tank used the same engine family across multiple variants, allowing maintenance units to stock fewer different power plants while supporting diverse tank types. Ford GAA, General Motors diesel, and Chrysler multibank engines shared mounting points and basic configurations, enabling rapid power pack swaps that put damaged tanks back into action within 24 hours. German armored forces operated without comparable standardization. Panzer tanks used Maybach HL 230 engines specifically designed for that vehicle. Tiger tanks required different Maybach engines with unique characteristics. Panzer IV tanks used yet another engine type. This diversity multiplied spare parts requirements, while making logistics planning exponentially more complex. A broken Panther could not use Tiger spare parts, and neither vehicle's components fit Panzer IV tanks. Sergeant First Class Michael O'Brien supervised a Sherman tank maintenance team attached to Combat Command A of the 3rd Armored Division. His crew of 8 mechanics could remove and replace a Sherman engine in 4 hours, using a specialized M32 tank recovery vehicle equipped with a winch and boom. The procedure had been refined through hundreds of repetitions until it became routine. Drain fluids, disconnect fuel and electrical lines, unbolt engine mounts, lift the power pack clear, position the replacement unit, secure mounting bolts, reconnect systems, refill fluids, and test the installation. German tank crews could not match this efficiency. Panther engines required removal of the entire rear deck plating, a process taking 16 to 20 hours, even with experienced crews and proper tools. Tiger engines demanded similar lengthy procedures. These time-consuming maintenance requirements reduced the number of tanks German units could return to service and created bottlenecks in repair facilities already struggling with parts shortages. The captured depot at Sankt Vith revealed additional dimensions of American logistical superiority that shocked Wehrmacht officers. Beyond major components like engines and transmissions, the facility stocked thousands of minor parts that German units chronically lacked. Spare vision blocks, periscopes, gun sight optics, radio equipment, fire extinguishers, toolkits, track connector pins, tow cables, and even complete interior furnishing sets filled designated storage areas. Feldwebel-Schmidt discovered an entire section devoted to what American supply documents called operator-level maintenance items. These included replacement final drive oil, transmission fluid, engine oil in 55-gallon drums, hydraulic fluid for turret traverse systems, coolant antifreeze, cleaning supplies, and lubricants of every description. Each item was packaged in standardized containers with clear labeling and storage instructions. German tanks operated chronically short of such consumable supplies. Crews often substituted inappropriate lubricants when proper oils became unavailable, accelerating mechanical wear and contributing to premature failures. Feldwebel-Schmidt calculated that the captured depot contained more consumable supplies than his entire Panzer division had received during the previous 3 months of operations. The organizational systems supporting American spare parts distribution demonstrated industrial efficiency that German logistics could not replicate. Each component in the Sankt Vith depot bore standardized nomenclature numbers corresponding to technical manuals and parts catalogues. Maintenance personnel could identify required items by referencing these numbers, eliminating confusion about compatibility and specifications. Storage areas followed logical arrangements that allowed rapid location of needed parts, with heavy items positioned near loading facilities and frequently required components placed in easily accessible locations. German supply systems relied on more chaotic organizational methods. Parts arrived in unmarked crates, requiring time-consuming identification procedures. Different manufacturers used varying nomenclature systems for identical components. Supply documents often failed to match actual inventory, forcing maintenance personnel to physically search through available stocks to find usable items. These inefficiencies multiplied the time required to complete repairs and reduced overall maintenance effectiveness. The American approach to replacement parts extended beyond simple availability to encompass quality control and reliability standards that surprised German technical specialists. Oberleutnant Weber ordered his men to test-fit several captured Sherman components, curious whether American quality matched German engineering standards. They discovered that transmission assemblies could be installed without extensive fitting and adjustment, unlike German transmissions that required hours of precise alignment work. Track links connected easily with standardized pins, rather than requiring careful selection to match worn components. American manufacturing philosophy emphasized interchangeability over precision tolerances. Parts from different production batches fit together reliably because factories maintained consistent specifications across production runs. This interchangeability eliminated the skilled craftsmanship that German maintenance required, allowing less experienced American crews to perform complex repairs successfully. The strategic implications of American logistical superiority became apparent as the Battle of the Bulge progressed. German tank units experienced steady attrition from mechanical failures they could not repair. By December 25, 1944, less than 40% of German armor committed to the offensive remained operational. Combat losses accounted for only a fraction of this decline. The majority of disabled German tanks sat immobilized by mechanical breakdowns that outpaced available spare parts supplies. American armored divisions maintained far higher operational readiness, despite intense combat. The 3rd Armored Division reported 75% of its Shermans remained combat-ready throughout December despite continuous fighting. Damaged tanks returned to action within days as maintenance units swapped out battle-damaged components and installed replacement parts from abundant supply stocks. Hauptmann Ernst Dietrich commanded the 2nd Panzer Division's maintenance company, responsible for recovering and repairing disabled vehicles. His facilities included mobile workshop vehicles equipped with welding equipment, machine tools, and lifting gear theoretically capable of performing major overhauls under field conditions. In practice, chronic spare parts shortages rendered these capabilities largely theoretical. Dietrich maintained detailed records of parts requests and delays that illustrated German logistics problems. On December 10th, he had submitted requisitions for 12 Panther transmission assemblies to replace units that had failed in recent operations. By January 1st, 1945, he had received 3 transmissions, all rebuilt units salvaged from previously destroyed tanks rather than new factory production. The other 9 requests remained unfilled. Similar delays affected every category of spare parts. Final drives took 8 weeks to arrive if they came at all. Road wheels could not be obtained in sufficient quantities to match combat attrition. Even simple items like spare track links arrived sporadically and in quantities far below requirements. Dietrich's maintenance company operated with approximately 30% of authorized spare parts stocks, forcing improvised repairs using cannibalized components and field expedients that reduced reliability. The captured American depot revealed that Hauptmann Dietrich's entire division's spare parts inventory represented less than 1/6 of the components stored in a single forward maintenance facility, supporting one American armored division. This 6-to-1 disparity in spare parts availability explained much about relative operational readiness between German and American armored forces. The industrial capacity that created American logistical advantages operated at scales German planners found difficult to comprehend. Ford's River Rouge plant alone produced more tank engines monthly than all German tank engine manufacturers combined. Chrysler's Detroit Arsenal tank plant stamped out Sherman hulls and turrets using automated production lines that achieved outputs no German facility could match. This industrial superiority translated directly into spare parts availability that sustained American combat operations indefinitely. Major Harrison's maintenance battalion consumed spare parts at rates that would have bankrupted German logistics systems. During December 1944, his units installed 62 replacement engines, 48 transmission assemblies, 93 final drives, and thousands of smaller components. Every replaced part went to core-level facilities for rebuilding or disposition. The supply system delivered replacement components within 48 hours of requisition, maintaining constant inventory levels that ensured sustained operations. German maintenance operations could not achieve comparable throughput. Limited spare parts forced Hauptmann Dietrich to prioritize repairs based on component availability rather than tactical necessity. Tanks with transmission problems might wait weeks for parts, while vehicles needing simpler repairs returned to service quickly. This parts-driven maintenance strategy reduced divisional combat power by leaving repairable vehicles idle for extended periods. The psychological impact of spare parts disparity affected German tank crews profoundly. Oberleutnant Weber's tankers had watched American armored units continuously replace combat losses while German strength steadily declined. The knowledge that American maintenance capabilities far exceeded their own created a sense of fighting against inevitable defeat. Superior American industrial capacity manifested not through better tanks, but through the ability to keep adequate tanks operational under sustained combat conditions. Private Werner Hoffmann served as driver for one of Weber's Panthers. He had operated his tank skillfully during the offensive's initial phase, but mechanical problems beyond his control had gradually reduced the platoon's strength. Hoffmann understood that his vehicle's 75mm gun could destroy any Sherman at long range, but he also recognized that American numerical superiority stemmed partly from logistical advantages that kept Allied tanks running while German vehicles broke down. The doctrine implications of spare parts superiority influenced tactical operations in ways German commanders had not anticipated. American tank units could afford aggressive tactics, knowing that battle damage could be quickly repaired. German units adopted more cautious approaches to preserve vehicles that might not be replaceable. This difference in operational mindset gave American forces initiative advantages that multiplied their materiel superiority. Colonel James Duncan commanded Combat Command A of the 3rd Armored Division, leading task forces that included Sherman tank companies, armored infantry, and artillery units. His operational planning assumed that 15 to 20% of his tanks would require maintenance at any given time, but he also knew that maintenance units could return most damaged vehicles to service within 72 hours. This planning assumption allowed aggressive operations that imposed disproportionate attrition on German forces. The captured depot at St. Vith provided intelligence officers with detailed documentation of American logistics procedures. German analysts studied maintenance manuals, supply forms, and technical bulletins that revealed sophisticated systems for tracking parts inventory, forecasting consumption rates, and coordinating distribution networks. These documents demonstrated organizational capabilities that German logistics could not duplicate even if spare parts became available. American supply forms used standardized nomenclature systems that eliminated ambiguity about component specifications. Each Sherman variant had detailed parts breakdowns listing every component with unique identification numbers. Maintenance personnel could requisition exact replacement parts by referencing these numbers, avoiding confusion about compatibility and fitment. The system worked because American Standardization ensured that parts lists accurately matched actual vehicle configurations. German vehicles lacked comparable documentation standardization. Different manufacturers used varying parts numbering systems. Field modifications created configurations that did not match factory documentation. Supply personnel often guessed about component compatibility, leading to errors that delayed repairs and wasted scarce parts on vehicles they could not fit. The transportation infrastructure supporting American logistics demonstrated another dimension of superiority that German officers found daunting. The twelfth depot's documentation revealed that replacement parts traveled from American factories to European depots using dedicated supply chains designed specifically for armored force support. Ships, trains, and truck convoys moved millions of tons of spare parts monthly, creating distribution networks that could respond rapidly to changing operational requirements. German logistics relied on increasingly disrupted transportation systems. Allied air attacks destroyed rail lines and bridges, forcing reliance on truck transport that consumed fuel the Wehrmacht desperately needed for combat operations. Partisan activity in occupied territories threatened supply convoys traveling from Germany to frontline units. These constraints reduced spare parts flow to trickles that could not sustain armored operations at required tempos. Feldwebel-Schmidt calculated that fully exploiting the captured American depot's spare parts would require transportation capabilities his division did not possess. Moving the facility's entire inventory would need 40 heavy trucks working continuously for 3 days. The division had 8 operational cargo trucks, and fuel shortages limited their employment. Most captured parts would have to be abandoned when German forces eventually withdrew from their advanced positions. The maintenance equipment captured at Sankt Vith revealed additional American advantages. Specialized tools designed for specific repair tasks filled tool chests and equipment lockers. Hydraulic presses for installing bearings, torque wrenches calibrated for precise bolt tension, specialized pullers for removing gears and shafts, and complete sets of mechanics tools enabled efficient repairs under field conditions. German maintenance units operated with far less sophisticated equipment. Tools were often improvised or adapted from civilian applications. Precise calibration equipment necessary for complex adjustments rarely reached field units. Mechanics relied on experience and skill to perform procedures that American technicians accomplished using specialized tools designed specifically for each task. Staff Sergeant Michael O'Brien's maintenance team carried tool sets that Feldwebel-Schmidt estimated were worth more than an entire German maintenance company's equipment allocation. Precision measuring instruments, specialized wrenches sized for Sherman components, portable electric tools for cutting and grinding, and complete spare tool sets ensured that American crews could perform repairs without equipment limitations. The training systems that created American maintenance proficiency complemented superior spare parts availability. Technician schools in the United States graduated thousands of trained mechanics monthly. Each specialist qualified in specific maintenance procedures through hands-on training using actual components. These graduates brought standardized skills to frontline units, creating consistent maintenance quality across the entire armored force. German training for tank maintenance personnel had declined significantly as the war progressed. Shortened courses eliminated detailed technical instruction in favor of basic familiarization. Qualified instructors had been transferred to combat units to address manpower shortages. Training equipment shortages forced students to learn procedures theoretically without practicing on actual components. These training deficiencies reduced field maintenance effectiveness even when spare parts were available. The Battle of the Bulge demonstrated how spare parts superiority influenced operational outcomes decisively. By early January 1945, German armored forces had been fought to a standstill not primarily through combat losses, but through cumulative mechanical attrition that outpaced repair capabilities. American armored divisions, despite suffering comparable battle damage, maintained combat effectiveness through logistics systems that delivered necessary spare parts continuously. Oberleutnant Weber's tank platoon exemplified German armored force decline during the offensive. His 5 Panthers had been reduced to 1 operational vehicle by January 10th. Combat had destroyed one tank completely. 3 others sat immobilized by mechanical failures ranging from transmission problems to thrown tracks to engine malfunctions. Weber lacked the spare parts to repair any disabled vehicle. His single remaining Panther operated on borrowed time, its transmission showing symptoms of impending failure that could not be addressed without parts his battalion did not possess. The strategic lessons from the Ardennes offensive's logistics dynamics influenced post-war military thinking profoundly. American doctrine, emphasizing robust logistics over vehicle sophistication, had proven decisive against German forces fielding technically superior tanks. The ability to maintain operational readiness through abundant spare parts and efficient maintenance systems had overcome individual vehicle performance advantages German tanks possessed. Major Harrison's maintenance battalion compiled statistical reports showing that spare parts availability directly correlated with operational readiness rates. When components arrived promptly, his units maintained division tank strength above 75%. Supply delays or parts shortages immediately reduced readiness as repairable vehicles awaited components. These correlations validated the massive investment American industry made in spare parts production and distribution systems. The industrial mobilization that created American spare parts superiority represented a fundamental shift in how modern nations approached warfare. Total war in the industrial age required not just armies and weapons, but entire economic systems organized to sustain military operations indefinitely. American industry had achieved this mobilization more completely than any other combatant, creating military capabilities that enemies could not match through tactical skill or operational excellence alone. The discovery at St. Vith of American logistics capabilities 6 times greater than German divisions possessed became symbolic of broader disparities between Allied and Axis industrial capacities. Oberleutnant Weber understood that his technical skills as a tank commander and his Panther's superior firepower could not overcome enemies who could indefinitely replace losses, while German strength irrevocably declined. As the Battle of the Bulge concluded with German forces retreating toward their starting positions, abandoned German tanks littered the battlefield as monuments to logistics failure. Many Panthers, Tigers, and other vehicles sat undamaged by enemy fire, disabled instead by mechanical breakdowns their crews could not repair. These tanks represented wasted production, trained crews without equipment, and combat power that never reached the battlefield because spare parts did not exist to maintain operational readiness. American forces, advancing across the Ardennes, encountered numerous abandoned German tanks in various states of mechanical failure. Intelligence teams documented these vehicles meticulously, noting that many required only routine maintenance or simple part replacements to return to service. The inference was clear. German logistics could not support the armored force Germany had fielded, making even technically superior tanks strategically irrelevant when they could not be kept running. The spare parts disparity revealed at St. Vith fundamentally altered how military strategists understood modern warfare. Victory required not just superior weapons but complete industrial systems capable of producing, distributing, and maintaining equipment under sustained operational conditions. American success in creating such systems while Germany failed represented a decisive advantage that no amount of tactical brilliance or technical sophistication could overcome. As the long and brutal winter of 1945 slowly gave way to the mud-softening warmth of early spring, the shrinking remnants of the German armored forces found themselves in a dire state, not merely because of enemy firepower, but because their machines had reached the end of their mechanical lifespans. Many Panthers, Tigers, and even the sturdier Panzer IVs sat, silently in fields, on roadsides, or tucked under tree lines abandoned not from battle damage, but from the slow grind of mechanical attrition. They were unable to move, unable to fight, and more importantly, unable to be repaired. The Wehrmacht had not lost its armoured might purely through combat. It had been defeated by logistics. As Allied forces advanced eastward deeper into Germany, their progress was rapid, not only because they held the initiative, but because their machines kept working. American and British armoured units moved with surprising speed despite difficult terrain and battered infrastructure. This was largely due to one invisible but indispensable advantage: logistics. The United States Army, in particular, demonstrated a remarkable ability to keep vehicles operational, whether in the muddy roads of the Rhineland, on the bombed-out bridges near the Rhine, or across the crumbling German autobahns. The contrast between the two sides became unmistakably clear. While the Germans still possessed isolated pockets of armoured tactical excellence, skilled crews, well-designed tanks, and lethal weapons, they had no functioning system to keep them moving. Wartime shortages had crippled German industry, forcing factories to produce tanks without producing enough spare parts to sustain them. In some cases, as historians would later note, factories produced tanks at a ratio of 1 spare engine for every 10 vehicles, while transmissions and final drives were nearly impossible to replace. Meanwhile, the United States had built a logistical machine that was unmatched in both scale and organization. American divisions received 6 times more spare parts than the entire German armored force combined. This astounding ratio was not random, it was deliberate, designed into the very structure of the U.S. Army's wartime logistics planning. Standardized designs, such as the M4 Sherman, had allowed the Americans to mass-produce interchangeable components, making repairs fast, simple, and reliable. Tank crews could swap out engines or transmissions in the field within hours. German crews often could not do so at all. American supply chains functioned like arteries across Europe, trucks hauling crates of spare parts, repair units working in mobile workshops, logistics officers keeping precise records of what was needed and where. Even damaged or destroyed vehicles were salvaged, stripped, and used to keep others running. It was warfare through organization and endurance, not glamour or spectacle. In contrast, German armored strategy had been built on tactical brilliance and elite technical design. Their tanks were powerful, uniquely engineered machines, but they were fragile in prolonged combat. Final drives shattered, engines overheated, suspensions froze or failed, and when these systems failed, there were no replacements, no supply trucks, no mobile workshops, no warehouses full of spare parts. The German armoured divisions, once feared across Europe, found themselves helpless, abandoned by the very logistical system that was supposed to sustain them. By April of 1945, many German armoured divisions existed only on paper. Their tanks were gone, not in flames or destroyed by enemy fire, but left behind as lifeless shells. Some sat nose down in ditches, some lined forest edges, others were simply parked in barns and sheds, camouflaged in the hope that someone, someday, might repair them. But that hope was never fulfilled. Ultimately, the frozen fields of the Ardennes had already revealed this truth months earlier. Panthers and tigers, often left intact, sat abandoned not because they had failed in battle, but because their armies could no longer support them. Tanks that could defeat any Allied vehicle in direct combat lost not to guns but to exhaustion, to neglect, and to the cold arithmetic of production capacity. In the end, it became clear that wars are not won solely by the strength of machines, or by the skill of the crews who operate them, but by the nation that can keep its machines moving longest. Tactical excellence may win battles, but logistics wins wars. And in 1945, logistics had spoken decisively. Up next, we have 2 more incredible stories that are waiting for you. Just click the image you want to watch, and it will take you there. If you enjoyed this video, make sure to subscribe. It would mean a lot.